Russia and the AI race. In the last episode, we evaluated China using the friction matrix and saw how its structure shapes its position in the AI race. The friction matrix is a framework we built to measure structural resistance to AI and automation. It scores 10 factors, from privacy rules to regulatory timelines to institutional mass, to estimate how easily a country can absorb rapid technological change. Now we apply that same framework to Russia. Join us to find out where it is advancing quickly, where it is moving with the pack, and where higher structural resistance may slow AI and automation adoption compared to other countries in our evaluation. Russia's friction score, 0.59. This is Russia's full friction matrix profile. After scoring all 10 structural factors and averaging them, Russia's final friction score comes out to 0.59. The scale runs from 0 to 1 and is relative to the countries in our evaluation. Around 0.5 represents the structural midpoint. Lower numbers suggest fewer barriers to rapid AI scaling. Higher numbers indicate greater resistance. At 0.59, Russia sits above the midpoint. That doesn't mean it cannot compete, but it does suggest that several structural factors may slow large-scale AI and automation adoption. The details inside the categories tell the real story. Where friction is low. Privacy is where Russia shows the lowest friction in our framework. It sits somewhat more rigid than China in this category, but more open and accessible than the other countries we measured. In the friction matrix, we use two privacy metrics as a proxy for large-scale data coordination. They measure how tightly a society restricts access to sensitive, high-value human data. In simple terms, they tell us how willing a country is to make structured personal data available so AI systems can help optimize economic activity. Russia has formal privacy laws and consent requirements, but the compliance structure is centralized and less procedurally dense than EU or US systems. There is less litigation risk, fewer supervisory layers, and more state-coordinated digital infrastructure. That combination means data is regulated, but not trapped inside heavy compliance systems, allowing smoother integration of data into large-scale AI platforms. Where friction is moderate. Safety measures how much protection a society demands before action is allowed. Does it rely on long pre-approval systems to prevent errors in advance, or can it move faster with after-the-fact oversight as AI systems improve information and reduce upfront risk? We use biotechnology as a predictive metric because it has historically been one of the most tightly regulated sectors. In Russia's case, approval timelines remain long compared to most of the countries we studied, and reform slowed after 2022. However, the cost of compliance is not among the highest. That creates a mixed safety profile, cautious on timing, but not extreme on cost. Digitization measures whether a society is willing to move away from manual and disconnected systems and allow digital platforms to observe and act within the economy. We evaluate this using two proxy metrics: digital identity systems and smart meters on the electrical grid. Russia shows another mixed pattern here. Digital identity systems have expanded rapidly, signaling strong centralized coordination and public participation. But physical infrastructure digitization remains well below the average in our study. Where friction is higher. Ownership friction measures how willing a society is to move resources when AI begins optimizing the economy by replacing labor and accelerating product life cycles. To make this measurable, we use job loss benefit access and payout levels as proxies. In Russia's case, participation levels and payout amounts remain modest compared to most of the countries we studied. That suggests limited willingness to detach income from employment during large-scale automation shifts. government friction is also measured using two signals. First, the share of the workforce in credentialed or institutionally protected roles. Second, the share of GDP generated by sectors that depend on statutory allocation or government-defined contracts. Together, these indicate how much economic value is tied to preserving existing institutional structures. Russia scores high friction in this category. A large and growing share of the workforce operates in protected or state-aligned roles, and post-2022 defense mobilization expanded the portion of GDP tied directly to state allocation. As more of the economy flows through these institutional channels, resistance to rapid AI-driven change becomes stronger. Russia's friction position, final insights. Russia's biggest structural advantage is centralized coordination. It has built strong national digital systems and does not place extremely heavy legal barriers around data use. That makes it easier for the state to deploy AI in administrative systems and other large, coordinated programs. The challenge appears when AI begins reshaping the broader economy. A large share of the workforce operates in protected or state-aligned roles, and income remains closely tied to employment. That makes it harder to move resources quickly when automation replaces jobs or changes how industries function. Since 2022, wartime mobilization has reinforced these patterns. As defense activity expands, a larger share of the economy becomes tied to state direction and protected roles. That makes broad structural change even harder to carry out. If this wartime posture persists during a period of rapid global AI acceleration, the risk is that Russia gradually falls behind in the AI race, while other countries may enjoy more freedom to reorganize their economies around AI. Join us next time to see how the United States scores in the AI race between nations.